In this lecture, we are going to discuss about relationship between zeros and coefficient of a polynomial. We will take different kinds of polynomials, linear, quadratic, cubic, and we will see the relation. First, we will take a linear polynomial. As the name itself says, the linear polynomial has degree 1. Line, it represents a line. So, linear polynomials standard form is ax plus b, where a is not equal to 0. Now, if we want to find out the 0 of this polynomial, we will make its polynomial equation, that is p of x is equal to 0. So, after equating it with a 0, we will get the 0 of this polynomial, which is minus b upon a. Now this we can simply write in words that what is b and what is a. Since it is a linear, there will be only 1 0, and we can say the relation is the 0 is equal to minus of b, means minus of this constant over here, and upon a is the coefficient of x. So this is the relation. Only 1 0, and in words we can write like this. Similarly, we will see for next polynomial, that is quadratic polynomial. Now, first we have learned linear. So its 0 is minus b upon a. Now let's see the second one, that is a quadratic polynomial. In a quadratic polynomial, if we write its standard form, it is ax square plus bx plus c with the condition a should not be equal to 0. Now, since it is a quadratic polynomial, there will be at most 2 zeros. And if we are taking 2 zeros as alpha and beta, any polynomial, quadratic one, when we write, it can be written in the form of the product of its 2 factors. Now these are 2 zeros, and when we know the zeros, we can write the factors like this. So this polynomial can be written in the form of its factors, and since quadratic, so 2 factors. So with the help of these 2 zeros, we are writing the quadratic polynomial in the form of its zeros. Now, in some quadratic polynomials, for example, 4x square plus 8x plus 4. If I am writing a quadratic polynomial like this, you can see that in all these 3 terms, there is a common factor, and that common factor is 4. So we can take out this 4 as a common factor. So ultimately the polynomial will be x square plus, after taking 4 out as the common, this will be 2x plus 1. So this 4 is a constant which can come in any of the polynomials, quadratic polynomials. So in place of this 4 is in this specific case, but we do not know what it can be. So for this constant, we will introduce one constant k over here. Clear? So the quadratic polynomial can be written in the form of its factors as a constant into product of its 2 factors. Now if we open this bracket and this bracket, when they are multiplied, it is in the form of one identity, that is x plus a into x plus b, where a and b both are negative. So we can write its expansion like x, this is ultimately x minus a into x minus b. So the expansion of this is x square plus a plus b into x plus ab. But since a and b both are negative, so we will take both negative. So here it will be x square plus, now this minus a and this also is negative, and it will be minus a into minus b. Ultimately the expansion will be x square. Now, this minus and this minus if we take out as common, so left out is a, and here this minus is gone out, so it becomes plus b into x minus a into minus b will be plus ab. Same way we are going to apply over here. In place of a and b, it's alpha and beta. So ultimate expansion will be x square minus alpha plus beta into x plus alpha beta. Now we have to compare each term of left hand side with the term of right hand side. First we will open this bracket, include this x inside, so kx square minus this k will be multiplied here, so alpha plus beta into k into x plus k into alpha beta. Now left hand side, first term is ax square. This ax square will be compared with kx square. So this will give us the value of a, because the common variable is x square will be cancelled. So ultimately the value of a is k. Now come to the second part. The second term is bx, and that will be equated with the second term on the right hand side. So bx is equal to minus of k into x plus beta into x. All terms are multiplied, x and x will be cancelled. So here we are getting b upon minus k is equal to alpha plus beta. Now alpha and beta are the zeros. So first relation we are getting here with the help of this sum of the zeros. So sum of the zeros of the polynomial is b upon minus k, can be written as minus b upon k. But what is k? K is equal to a. So this relation we have got, that the sum of the zeros of a quadratic polynomial is equal to minus b. What is b? The coefficient of x upon a. And what is a? The coefficient of x square. So these are the relations. So first we will write, that is alpha plus beta, that is the sum of the zeros, that is minus b upon a. And previously what we saw, the last third term was c, and on the right hand side it was k alpha beta. Now here it will give us alpha beta is equal to c upon k. Now this c upon k we will rewrite, because we want the coefficients and the constant. So alpha beta is what? Product. So the product of the zeros is c upon a. So what we have got? The sum is minus b upon a and the product is c upon a. So for a quadratic polynomial, which is in the form ax square plus bx plus c, the sum of the zeros, alpha plus beta is minus b upon a, and product, that is alpha beta, is equal to c upon a. Let's see about a cubic polynomial. Its standard form is ax cube plus bx square plus cx plus d, where a is not equal to 0. Now since it is a cubic polynomial, it will have 3 zeros. So let's take 3 zeros, Greek letters alpha, beta and gamma. And as we know, a polynomial can be written in the form of its product of the factors. So the 3 factors will be x minus alpha into x minus beta into x minus gamma. The same way we will introduce a constant as we had done in the quadratic polynomial, and we will write the standard form this side. So ax cube plus bx square plus cx plus d is equal to k into x minus alpha into x minus beta into x minus gamma. If you find the expansion of this, it is actually two brackets. First we can solve and multiply it by the third one. The final expansion will be x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma. This is the expansion of x minus alpha into x minus beta into x minus gamma, sorry, not alpha. Clear? Now, when you write this k, means when you multiply this k by all the terms, this expansion will become now kx cube minus k into alpha plus beta plus gamma into x square plus k into alpha beta plus beta gamma plus gamma alpha into x minus k alpha beta gamma. This, if you notice, this is the sum of three zeros. This is sum of two zeros at a time. This is product of zeros. Okay. Now we will compare the left hand side with the right hand side and we will get the relationship between the zeros and the coefficients. So now let's equate one by one all the terms. First term is ax cube. That ax cube is equal to kx cube. So this will give a is equal to k. The second term, that is bx square. Bx square is equal to minus of k into alpha plus beta plus gamma into x square. On the right hand side you can see three quantities are multiplied, x square cancelled. So here alpha plus beta plus gamma is equal to, this k will go down. Okay. So b upon minus k, that is minus of b by k. So minus b upon a. So what is alpha plus beta plus gamma is the sum. So sum of the zeros of a cubic polynomial is minus b upon a. Okay. Now similarly we will equate the third one. So the third term is cx over here and this is k into this. So third is cx is equal to k into alpha beta plus beta gamma plus gamma alpha into x. X and x will be cancelled. So we will get the value of alpha beta plus beta gamma plus gamma alpha. So alpha beta plus beta gamma plus gamma alpha is equal to c upon k, that is c upon a. Why? Because a is equal to k. Now the last is left out, that is d is equal to minus of k into alpha beta gamma. So that if we will equate, d is equal to minus k alpha beta gamma. So alpha beta gamma is the product of the zeros is equal to minus d upon k and k is a. So that is minus d upon a. There are three relations. First relation is sum of the zeros of a cubic polynomial. That is alpha plus beta plus gamma. That is minus b upon a, where b is, your standard form is ax cube plus bx square plus cx plus d. So b over here is coefficient of x square and a is the coefficient of the leading term, that is x cube. Now the second one is two zeros at a time and its sum. So that relation is alpha beta plus beta gamma plus gamma alpha is equal to C upon A. And the third relation is the product of the zeros. So the product of the zeros of a cubic polynomial is minus D upon A, where D is the last constant term and A is the coefficient of x cube. So what we have seen, these three relations of cubic polynomial. Now we will see the verification of these relationship between the zeros and the coefficients. Let's take first linear polynomial with the example P of x is equal to 2x plus 3. So the 0 will be minus b upon a. X should be equal to minus b upon a. Here if you want to find out the 0 of this polynomial, we have to make its polynomial equation. That will be P of x is equal to 0. So the 0 of this polynomial is minus 3 upon 2. Now look at this minus b upon a. Minus 3, here b is 3. So this will be minus 3 upon a is 2. So that is coming. So you can say that what relation we have written over here and what 0 we are getting, it is been verified. Similarly, we can do for a quadratic polynomial also. Let's take one example of quadratic polynomial. The second is any quadratic polynomial x square minus 2x minus 8. Quadratic, degree is 2 and the relation is the sum of the zeros should be minus b by a and the product is c by a. So first we will calculate or we will find the zeros of this polynomial. So to find the zeros of this polynomial, we will factorize it by splitting the middle term. The last term is 8. 8 we have to find two factors of 8. This is minus 8. But those two factors you have to choose whose sum is the coefficient of the middle term. So two factors if we are taking 4 and 2, but since this is negative, so the bigger factor we will take negative since this sum is a negative quantity. So two factors we are going to take minus 4 and 2 because minus 4 plus 2 is equal to minus 2. This should match with the coefficient of the middle term. So we will further write it as first factor is minus 4, so minus 4x plus second factor is 2, so 2x minus 8. Take the common factor x among these two. This is x minus 4 from these two. 2 is common. So now x minus 4 is common. The second factor x is left out from here and 2 is left out. So second factor is x plus 2. Now the two zeros, when you get the factors, we will make this as a polynomial equation. So p of x is equal to 0. So x minus 4 into x plus 2 is equal to 0 will give us the two zeros of this polynomial. So either this is equal to 0 or this is equal to 0. So when x minus 4 is 0, the value of x as 4. And when x plus 2 is 0, the value of x as minus 2. So by these factors we have got the two zeros. Now let's see the verification. Here in quadratic polynomial the sum should be minus b upon a. So the polynomial is x square minus 2x minus 8. Here a is 1, b is minus 2 and c is minus 8. So let's see now the sum of the two zeros. The two zeros what we have got are 4 and minus 2. If we do the sum of these two, this will be 2. And the sum should be minus b upon a. Here minus b upon a will be minus of minus 2. And what is a? 1. So that is equal to 2. So what actually we have done the sum and what we have applied the relation, that is coming same. It means it is verified that the sum of the zeros of a quadratic polynomial is minus b upon a, means minus of coefficient of x upon coefficient of x square. Similarly, we can check the product. So, here the zeros are 4 and minus 2. So, the product of zeros will be 4 into minus 2. So, 4 into minus 2 is minus 8. But the relation says it should be C upon A. So, we will check this C upon A. C upon A. C is minus 8 and A is 1. So, we have observed that what on actually multiplying this means finding the product and applying this relation, it is same. So, it is verified that the sum of the zeros of polynomial is minus b upon a and the product of zeros of a quadratic polynomial is c upon a. On the basis of the relationship, what we have seen for quadratic polynomial as sum, that is alpha plus beta, is equal to minus b upon a and the product, that is c upon a. We can also form a quadratic polynomial when the sum and the product of the zeros is given to us. Means the formation of a quadratic polynomial if the sum and product is known to us. So that form is P of x is equal to this constant we have to take as I had explained in the earlier case. Then the polynomial will be x square minus sx plus p, where s is the sum of zeros and p is the product of zeros. It means that if we know the sum and the product, we can also form a quadratic polynomial. Let's take one example. This is the form. If the sum of the two zeros is given 4 and the product of the zeros is 1, form a quadratic polynomial. Directly we can say the polynomial will be x square minus, this is 4, so sum is 4 and plus product is 1. So directly we can write by this form that when the sum and the product is given, the polynomial will be x square minus sum of the zeros plus product of the zeros.